Yeah, just a brief recap of who I am. Gijs Van Der Velden. I led the bridge project in Amsterdam, which is now nearing its completion. As just mentioned, we have taken away the temporary bridge, and our bridge is going to be placed. Of course, Corona can put some delays on still, but that's hopefully manageable. A project that we did, also of course limited budget, but mainly to break free from the restraints of this the objects that people have been printing, and limited to 70 centimeters and then 50,000 euros. We said, okay, we have to come up with something that allows us to make this scale jump, and this bridge shows that that's possible. So of course, together with the Imperial College London, it's extensively tested, I mean, approved because it's going to be in a very busy area in the city, so it has to withhold a lot, and it cannot fail. But we included also a sensor system that allows us to understand how a structure behaves. So of course, we don't know yet how this material is going to behave over the next 50 years. We're in it for the long game. Additive manufacturing is going to take at least, especially for architecture, 10, 15 years to come up with both the business case, but also all the science behind it that is required for the safety concerns. And this sensor system that we have installed will help us with that. So of course, we understand how it's behaving now when put under pressure, but we want to understand how it's behaving when the sun is on there, when it's lying around there for 2 years or more, and when you have special events that we haven't thought about or couldn't test. So this really allows us to go one step further into the optimization process in the future. Just quickly for people that don't know wire arc additive manufacturing, that's the basic technology. So we use a welding robot and a piece of software that we created to print either layer on layer or dot by dot. And here you see it sped up a bit. So also my comment before, it's a relatively slow process for architecture. You have to imagine 2 to 3 kilos per hour when putting down, an FDM kind of strategy. And if you do dot by dot, then 2.5 meters is already a good achievement, 2.5 meters per hour. So it definitely solves a problem in the area beyond the metal printing that we have now. So we can print bigger objects sensibly and economically, but still for architectural size objects, it's challenging. So we work a lot on the automation. So of course, when you cut out the human labor side and everything goes fully automated, you have more of a chance of it becoming an interesting technology for companies to use, because maybe it takes a bit longer, but it doesn't need any staff, so that the cost there is less. So we created a small slicer, but also connected to a sensor package that allows us to monitor and adapt while we print. Relevant to this session, I think, is whether a technology like this could have a space application. And I think one of the real benefits of additive, but also this technology, is that you can reduce the weight of the parts you need. And when I was researching for the next speaker, I also saw that this is important because the rocket equation says that it pays off significantly when you minimize the structural mass of the vehicle. Less mass is good for space, and therefore we can consider printing larger rocket parts. So this is a relativity space. A colleague of us in the WAM industry solely focusing on printing vessels. But I guess this is for space. But one of the questions we also want to discuss today is whether we can print in space. We of course dream of this. Whenever we have time, we print interesting objects. to keep ourselves enthusiastic for this. Yeah, our technology has a couple of disadvantages. Of course, you need a lot of power, you need gas, which blows away out there, and you need to bring all the materials there. So whether that's feasible, I don't really know. But obviously there's already a lot of people thinking about how you can work with local materials, which seems to have a lot of potential. But then of course you need some type of full automation and artificial intelligence to solve all these problems that you encounter.